mode. So I want to kick this off. This is a presentation by Ubisoft discussing how USD is utilized. I'll let them speak more to all of that. But before I set them off on that, I want to introduce who they are. We've got two speakers today. We have Cyrus Rahgoshay. He's been with Ubisoft for 10 years, tech lead, R&D software engineer. Cyrus has been involved with Ubisoft games, films, characters, animation pipeline team on well-known titles such as Assassin's Creed, which I love personally. Rainbow Six, I love that as well. Far Cry and Watch Dogs. I love all of Ubisoft stuff, it turns out. I'm a big gamer nerd, so kudos to you guys for all those awesome games. We also have Alessandro Bernardi. He's Director of Technology at Ubisoft Montreal. He's been there 12 years as Pipeline TD and Head of TD and Pipeline at Ubisoft Motion Pictures. So with that, I was going to let these two guys carry it forward. Oh, one quick thank you. This is sort of off script, but I have to do it. I love the Pipeline Conference. I have to say, these guys blow me away every time they put something together. The amount of people they attract is amazing. It's all on their personal time. I don't know if you all know, it's definitely a nonprofit. This is just people in their busy work lives putting that little extra time in so that we can all get together and hear about things like that. So just a quick shout out to them. I'm always happy to volunteer for anything that these guys support because of all the great topics and things that they do. So thanks to them. And with that, I'm gonna let Cyrus and Alessandro kick it off.
Well, thank you very much. Thanks, Doug, and thanks to the whole TPC folks. I mean, you guys did an amazing job, and it actually was a very, very good honor for us to be presenting. So, hi, everybody. I'm happy that you guys are all here. Good morning, good afternoon for some of you guys. So today talks, we're going to be talking on how USD is supporting the evolution of film and game pipelines with Alex. So let's just get it started. Well, my name is Cyrus. I am a technical lead at Ubisoft Montreal. My background is in computer graphics, in specifically physically based simulation. I worked in simulation industry called Serious Games, and then I joined the game industry. I've been working more than 14 years in game development, and 10 of those has been actually in Ubisoft Montreal, specifically in the Helix team. I worked on different asset production pipelines, game to film pipelines, a lot of cool R&D projects, and I contributed to some of Doug's favorite games, actually, Assassin's Creed, Rainbow Six, and Far Cry and Watch Dogs. So who we are a leading game publishing company in the world. We are more than 21,000 people, span across 45 different studios in 30 different countries. And one of those studios is actually the Montreal studio, and we are a service team called Helix with roughly like 900 people with different range of expertise. Out of them, we have more than 60 artists with different backgrounds and different set of skills, and we support those guys with a team of 12 developers. But enough of talk. I would like to show you just like a 2-minute demo reel just to give you a bit of a feel of like what we do at Helix.
Up the pieces again, but it's clear that you wanna sit and watch me lament. I'd swim through the ocean just to show you I've grown, but you won't dictate what your future is and where you will go. In which state is your mind and how does everything flow? Don't stress, cause the world is only what you can make. Don't mistake. Fire it
Well, as you can see, we are an inter-service team that we work with many of our AAA games. We're tasked to provide them with like marketing asset. We also help them like create asset that goes within the game. So all you saw was a mix of different kind of assets that we produce. There's a lot of like 2D, 3D illustrations, in-engine captures, offline CG. So it touches a big range of production. So we're not really just like a game producing team. We're actually more or less like some sort of a little VFX studio within the game company. So we're not that different from the movie industry. And with that, we also have our own set of challenges. So when we looked into the pipelines that we wanted to produce and the type of assets that we wanted to produce, we saw that like every other team, we all have different mandates, like production demands are ramping up. We have a lot of assets that we need to produce, but also the tech is evolving around us. We have so much new technologies, and we want to be able to benefit from all of those. The other challenge that we have is that by the game companies producing better engines, and better engines means more assets. So we need to produce a lot of digital assets, and those digital assets will not just live offline somewhere on the hard drive. They will all stay within the game engine. And as we produce games that are bigger and longer and last within the life cycle a longer amount of time, well, those assets needs to stay in the engine and then be used later on. Also, as you saw, we have many studios, we have many different teams and platforms around the world. So they all need to communicate. Like one game, like an Assassin's Creed, it might be developed by 7, 8, 10 different studios all across the world, from China to States to Europe. So everything that we produce needs to be accessed and exchangeable between different teams. And as I mentioned, games are getting longer and longer. We have game as services. So then you create a game that come out like Rainbow Six, but then every year you produce new seasons. So all of those challenges pushed us around like in 2021 to do some research. And we came up with like a publication that we published at Digipro 2022, which was how do we build scalable and evolutive USD pipelines on distributed architecture at Ubisoft. Through this talk today, I'm just going to quickly go a little bit through the research that we did and our experiences with USD, and maybe give you a little bit more of like some of the background that and our experience with it. So for the Digipro research publication, what we decided initially was that let's just came up with a use case. Like what did we want it to do? We just wanted to create like an offline game asset library. That was our use case. At Ubisoft, we have our own proprietary game engines. We have Snowdrop and Anvil that we develop our games with. So there's a lot of game data that is produced by the production teams and by their artists and exist in the game engine. So we wanted to be able to extract those game data in their native format and then be able to convert them to something uniform, such as USD, and essentially store that in the cloud and then use that data that is stored to populate an offline game asset library. So in order to achieve that, we decided that we need to kind of basically renovate some of the pillars of our technologies and our existing pipelines. So the first pillar that we looked at was how do we want to control this? So we looked into our workflow creation. Like most of other teams and different like VFX studios or game studios, we had this sort of basically hard communication between supervisors and developers, and they're all very dependent on each other. Because of the legacy pipeline that we have and a huge amount of code that we had, every time a supervisor wanted to introduce like a new change or wanted to propose like a new R&D idea, well, they always had to go to developer and ask them to, can you just whip up a piece of code for me or just do something and then make a big change to the code. So that was very tedious. It kind of didn't really work for everybody. And it also didn't really promote the idea of like being able to produce, prototype, and iterate on it. So we looked around and we find some solution in different industries like automobile and retail. And we find an idea was BPMN, which stands for Business Process Model and Notation. And essentially, we just wanted to give a control to our supervisors in the form of a modal and a nodal approach. So supervisor could define their processes and their human interaction as visual nodes. like for example, processes like production tracking, file submission, media encoding, notification system, they can all be defined as separate independent node. When you define your workflow, then you can actually give that workflow to the developer and then write the code for it, make templates, version it, scale it, and at the end, just like expose them to supervisors as an interface. So that was our first basically way in order to have some creation like autonomy for our supervisors. The next pillar that we looked into was actually, well, I mean, we have a lot of data, we have a lot of file formats, but I mean, in order to be able to collaborate, can we actually use like a uniform file format? And for us, it was almost like a no-brainer to look into USD. But before going into that, I want to just open a quick little like a background on what was our adoption and our basic experience with USD. So as most of you are aware, USD has been adopted by the industry heavily since its release in 2016 by Pixar. And the more and more VFX companies were using it, like game industry got interested. So then now you see more and more teams are willing to use that and collaborate using it. But our first experience about adopting USD at Ubisoft was actually in 2016. We had like an early release version of USD that we worked with it, and Alessandro specifically looked at it. And when we started really working with it was at the turnaround of the season 3 to season 4 of Rabbids Invasion in 2016. We had an old legacy pipeline, and when we looked into producing the new season, we knew that we're gonna have to look outside and we're gonna have to look into different solutions. It was a risky bet, but it paid off, and we managed to produce those seasons, and they were a good success. But at Helix, we looked into USD a little bit later than that, in 2022. Why did we look at it? It's because being a team that worked with different AAA games, we had almost a very unique spot within Ubisoft to be able to look into something for exchangeability and interoperability. We were integrated in different game engines, we had their data, and also we were benefiting from having a different set of profiles in our teams. So people that work for us, based on what you saw in the demo reel, there are people that came either from the VFX industry, movie industry, or were within the content production or asset creation within the game industry. So they were all pretty familiar with the format and with the potential of that tool. So in 2022, that was actually when we worked on it, and then we produced the Digipro paper. But if I want to open like another subject, is that, well, everybody talks about USD in films and games, but what is it actually that is the common joint factor between the usage of USD within those two basically industry? It's easier for us to see what is not the same within both industries. So from the beginning, when USD came out by Pixar, it was essentially something that was made in order to be able to use for keyframe animation. In the game industry, like, we're not really working with keyframe animation. Everything is real time. So we need a lot of real time streaming. We know that DCCs that are used in the game and movie industry are very, very, very like powerful tools to be able to work with USD. Scene manipulation is great, you can work with it. But when you look into game engines, it doesn't really work for us, because I mean, even though we have very powerful engine right now, good hardware, but still the streaming of the USD data as a real-time performance, if you want to satisfy 30, 60, 120 FPS, is not something that we can do. I mean, if you really need to be refreshing your scene graph for 60 frames a second, well, I mean, USD is not really performant at this point so far for it. And the other difference that we have within the movie industry is that, well, we can use USD in order to represent our 3D data, but then we lack a lot of native support for non-3D data that it's used in games, but not necessarily in movies. For example, we have procedurals, assets that are created within the game engine. We have character inventory data. So those are stuff that might not be necessary for movies, but we do need it. So that kind of limits the game industry on using the USD to more the usage of USD as a data transport. Something that we use in order to do asset creation with, or actually for some pipeline and tooling. But when we look at it on the other side is what are our common goals and our commonality with two industries? I mean, as game engines are getting better and better and more performant, we're adopting algorithms from the game industry and also from the movie industry. We're able to have more physically based rendering. Like you can see with different game engines, such as like Unity and Unreal, like now you can do real-time, basically movies, real-time rendering. You produce some of the movies shots in game engines, vice versa. So the conversion technology and the solutions is actually a benefit for everybody. We're more and more using each other's assets, each other's technologies. And so far, there's also a big lack of standardization. It's a new format, everybody's using it, but still, there's a lot of stuff that are missing for all of us. For example, like everybody's like suffering from rig and animation schemas, like they're missing within USTs or they're not really accommodating to our needs. But also everybody's benefiting from some of the uniform solution and schemas, like solutions for materials, textures, like Material X. So overall, everything that is introduced, more standards, is all welcome from both industries. And we have a great community, like everybody's willing to contribute. It's an open standards, like, and more companies and DCCs like Adobe, Autodesk, Side Effects, they're all using it. So that's a great news because now like new proposition and new discoveries within the field, it kind of benefits everybody. Like one of the community work that we did at Ubisoft was like we worked, for example, on proposing new schemas for USD. I'm not going to go into those details, but like we had great people at Ubisoft, a great team with Alex, Charles Flesh, and like other people that worked on proposing, for example, LOD schemas for USD. We know that in movies, like LOD can be handled, LOD, most of you are pretty familiar with it, but we're talking about level of detail. So when you produce assets, you might produce assets with different level of details that you want to be able to render in your scene, depending on how far or how close you are to that asset. So that's a very pretty known concept in movie. Like you can handle it with variants, payloads, and DCC tooling. But when you go into game engines, it's a whole different story. The resolving of that LOD is not done at load time anymore. Like you don't have a shot like a movie that you can just say, all right, I have these fixed LODs in this scene and load those for me. You actually play the game and you walk in Assassin's Creed, you walk in a big game that you can walk from 20 minutes from one side to the other. And everything needs to be resolved while you are in your render time. So you cannot really base yourself on like how you store that object or how you store that LOD and how that shot is supposed to show this thing. I need to resolve it as you're getting into those places or those assets are visible to you. So you cannot do any assumptions on how do you want to trigger those assets. Most of them would be probably stuff that we propose. It would be like maybe the loading needs to happen based on some triggered behaviors of physics, like for example, some animation, some camera movement, depending on where you are within that object. So the other proposition was that these need to be frame deterministic because it's not like a simulation that you can base yourself on the delta of frames before and after to predict the LOD. It's every frame needs to have its own set deterministic value. These were proposals that we submitted to ASWF, and you guys can actually go and click on it. But all in all, to say that, you know, once you produce something, it doesn't matter which industry, everybody can benefit from it. So those are great stuff. So all of that led to basically like USDB the way to go for us in order to be able to have a file format that can be interoperable between our different DCCs, game engines. And also it really helped us when we wanted to package our asset and send them to some external like teams and external marketing agencies. The third pillar that we looked at was how do we want to identify our assets and resources? So we create all of these games and we produce all of these assets, but like the identification of those resources were actually a big issue for all of us. What you can see here is it's interesting because within the game production lifecycle, we might not follow the same lifecycle of a movie. A movie might just get produced, finished, move to another one. But as we're developing games as services, games are producing a longer life cycle. So your game can go gold, they can be released, but then a few months after, you're going to have new downloadable content, you're gonna have expansions, and some big franchises, for example, like Assassin's Creed, they can come back years later, like 10, 15 years, and then make anniversary content. And then within those anniversary assets, you wanna basically create the asset, which is the initial Ezio that was produced maybe 15 years ago. So you see that as game produces and then games age, the ownership of that game can be transferred to a different studio. So the asset that were used and produced by one studio needs to be accessible by the other studios. And then, so we need a solution to be able to kind of disconnect the physical storage of those assets and the identification of those assets from the actual studios that were owning and producing those. So for that, we used the URI. Most of you might be familiar with it. URI, it's like a URL. So it stands for Uniform Resource Identifier. And we can represent a production asset using a string that you can see here in the slide. So URI is decomposed of different basically components. So we can use the scheme, the authority, and the path to represent the actual assets. For example, you can say that's a specific asset from this production, from this studio, from this game, and from this type of mandate. Those are normally the static information of the assets that can be fixed, then anybody can access it. Now that you can access your asset, you can also represent the production states of that asset using query and fragment. So we can use work group, status, format, LODs, and those are parameters that evolve as the asset is produced by different teams. So we try to be very uniform and use defined terminology and industry standard vocabulary for those terms. Most of the VFX industry are using the same terminology. And using that, now we were able to have basically a single point of entry in order to be able to identify our asset. So you can use a URI resolver, and it doesn't matter where your asset is stored, either game engine, a hard drive, someone's PC, or somewhere on the cloud, you can always identify and access your assets. Moving forward, then we looked at how can we actually scale our pipelines, and we looked no further than microservices. Not to go into too much details, but microservices are great, and why they're great is because, well, they're language neutral, so you can produce different services by different languages. Like you can code in Python, Go, C++, and anybody can actually work on it. So we looked at our whole pipeline and big legacy code, and then we just divide the whole pipeline in little chunks that they do one thing, but they do one thing really good, and then they created different microservices. That also allowed us to be able to leverage a lot of in-house technology. So you might want to ask why you want to use microservices, because a lot of stuff might come not for free, but at least from previous investments and different tools that you created. So like we had internal databases, cloud storages, like a Kubernetes orchestration, AI tagging systems that we could use, like a thumbnail generation. So you create your services, you plug everybody to it, and then everybody can benefit from it. The other key idea was that, well, I mean, it really helped us to be able to orchestrate our different artist deployment, asset transfer between different studios from different sides of the globe. And also, well, once you use single point of entries for a lot of your things, you have a lot more control, and you have a lot more secure channels. Like we use the microservices, our entry point for our software tracking tools, such as like ShotGrid or Jira softwares. For that project, we developed different microservices. Like they kind of range from different things, from like production tracking, asset tracking, resource resolvers, and storage. But also we had like fun microservices, like thumbnail generation, like a turntable generation. So you can just name it. Like anybody can just whip up like a new microservice, and everybody can benefit from it. So going back to our initial idea, like we basically had all these pieces, and then we managed to create like an application which was like our offline game asset library. So what you see here is actually gameplay footage of one of the expansions of Assassin's Creed Valhalla. Well, that's like a world in Assassin's Creed. It's Asgard world, and well, you see there's a lot of assets, and like all those assets are not just stored in one place on someone's PC. It's contributed by different artists from different teams, and they're all kind of built, sometimes even created within the game engines, like shaders, materials that sometimes like procedurally generated within the engine. So that kind of differentiates us from different games, from different industry, is that all of those assets live within the game engine. So we were able to basically go and look into an engine and now propose to our supervisors that they can go and do some location scouting. So a supervisor would go play the game, would position itself whatever they wanted. We had tools that they can just transport, teleport there. And maybe, for example, the supervisor liked this scene and they wanted to create like a marketing assets that encompass like somewhere here in Asgard and using this like some of these assets. So they could just position themselves where they wanted, like basically do an extraction of the assets. And then that extraction UI would basically start the process that developed, like that nodal approach that they created. So they created this sort of graph that they said that I want to extract stuff, I want to convert things to USD, then I want to be able to create my resources and then submit everything to the cloud. So that process was automatic. I mean, being also on microservices, we were able to monitor the whole thing using Grafana. So that was like really, really good to monitor and see the process and the bugs. And essentially at the end, you would end up with a big asset library that you can just browse through and see all of your game's assets. Because everything comes from the game engine, we also had availability to be able to properly name them, tag them, have all sort of information. Nowadays with like AI and everything, you see how much power you can actually get using such a well annotated library of assets. Then once you have that library of assets, then you can actually just browse through it. Your supervisors, your art director can come up and they can pick and choose assets and build a scene. So like that would be like a Maya scene built offline using those assets. And then you can just now basically give that to an artist and then they can do the magic that they do and iterate on it. So once everything works perfectly and you can basically create these stuff, then you're able to kind of utilize in-game assets like do some high resolution on it and then do some offline work or back in the game and eventually like come up with great images like this, you know? So like you see how powerful these tools can be in the hands of the artist if you can provide them with the actual proper asset that they need. So that was great. And we concluded at Digipro that, well, I mean, in order to have good pipelines, we kind of need to have some sort of a nodal approach, give more flexibility to people to work and propose ideas. Definitely, we needed some uniform data format, so then we can kind of like elevate the power of that format and be able to work no matter where, with no matter what DCC. And we managed to also handle the identification of our resources and be able to have something that actually can scale beyond just our studio and to different teams. So that was great. And then we moved on and then we looked into, okay, so what else and what are the other challenges that we can tackle? Now we have an application. Can we produce maybe like a pipeline or some sort of a workflow or collaboration thing? We looked into like a different use case. We thought and like, okay, what do we produce at Helix? Well, I mean, we do a lot of animation and we produce assets that are animated. So why not look into that? When a little parenthesis is like, when we look into animation, DCCs, data content creation tools like Maya, Mobu, and everything are very powerful. Like they're kind of made for animation and tailoring the animation and creating the animation. But game engines are not made to work on your animation. They're really good to represent it, but like it's not really a good workflow. So it's not a good way to collaborate and create animations. And a lot of people are coming with trying to find different tools and pipelines to do that. Like most of you are pretty much aware of Omniverse. Omniverse is some sort of a collaboration tool. So it's a multi-user, multi-tool collaboration system and environment. So we tried to do something like a little bit less complex. I tried to reduce scope and complexity. So we opted out for like a single user multi-tool. It's a SIMD analogy basically. So what you wanted to do and like what like in this case is that we wanted to have something simple. So we wanted to have the data as the center of our pipeline. So we decided to have a server that is operating on a gRPC layer that is the sole owner of our data. The server is basically a USD stage. We can have different client that connects to it asynchronously and be able to look at a stage of data that we can control. So how does that work? It's like we decided to look into, if we look into the animation, well, can we actually have now a collaborative animation editing pipeline? For this, we looked into having the server that loads a USD stage, and every client can connect to it and be able to modify that that asset within the server USD stage. This was allowing us to be able to have data at the center of our pipeline, and also the single source of truth of our data would always stay within that server. So you can look at it, for example, if you want to project a little bit more, is that you can have a game engines that connects to this server, and at the same time you have a Maya or a Mobu that would like to make some animation changes to your scene that connects to that server. As the client is modifying the animation within your server, the game engines also receives those changes and can actually start and look into basically visualizing it for you on the game engine side. We went a little bit, like we didn't go too complex on what we wanted to handle. We looked very on some basically minimum manipulations. We were looking into just changing exformables and joins and transforms. And we hooked up our offline game asset library to that server to be able to visualize that workflow and see whether or not that actually can be working. What's great with that approach is that your data is at the center, your source of truth is at the center, and as long as you have a client that can support USD natively, you're good to go. I mean, it's the low-hanging fruit on the side is that the whole code on how to handle USD is like boilerplate code within your DCC. And also, in addition, then you can have, if you have, for example, in UCC, you have the ability to have like a USD Hydra delegate, you can always have your own visual representation of the data. So just for the sake of representation, what you see here is I didn't put any engine, but like we have two Maya clients basically that they are connecting both of them to our data server that is loading a asset from the asset library. So the Maya on the left actually communicated with the server and asked the server to load a stage. And the other Maya right away received that scene in its own environment. What's interesting when you look at it is that every single client, the Maya to the left or Maya to the right, no matter who initiated the loading of that stage to the server, is able to manipulate an asset within that scene. So we, as we said, we supported at this point just joints and transforms. So each client could manipulate a part of that asset. What was great is that like with using the power of the USD, like we could save all of those changes just in the edit layer, and then the scene did not have to be changed or polluted. And we were able to basically see and have a collaborative workflow and environment for our different clients. Another client can be in the game engine. So you can, for example, you can do your animation in one side in the DCC and then see the result as you want it to be shown in the game engines. I mean, specific workflow and situation for that would be you want to animate a character, but right away you want to see how the look and feel and the look dev in the game engines. So that was great. And it kind of validated some of the approach that we have, and it gave us a lot of ideas on how we can basically move forward and create more collaborative pipelines and using the existing application that we created. So what are the upcoming challenges that we have? Well, I mean, all of you know that producing new tools and R&Ds and pipelines is great, but while you're working in active productions, like you cannot really break your code, you cannot really start putting time aside. So this is definitely a lot of like management challenges and a lot of like basically planning to be able to find the time and also find right avenues to create those tools so they can be beneficiary later on. We realize that standardization is actually very good for everybody, and definitely everybody would benefit from having one format. But the most important thing of them all is that, well, you just have to try it. Like it's really nice to see all those nice videos, but like once you try it, then you start getting creative. Once you can get the input of other people and people can participate and find more ways to elevate your tools. So we concluded some of those terms at Digipro, but like, what do we conclude now today? It's, well, pretty much all of the stuff that we did still valid for us. And in addition, when we worked with USD, we realized the power of that file format, and that was that the USD gives us the ability to erase the asset history. So it didn't matter who created the asset, where it was created, where was it stored, when was it stored. As long as we had that asset and that asset was in a server, anybody that could read the asset, they could access it and work with it. So that was like a very, very good, powerful, basically conclusion for us. Well, with that, I'd like to thank our team here back in Montreal, Alex for being here with me, and Anna, Anthony Mazier, and Robin DeLeo. But also special thanks to some of our old colleagues and existing colleagues like Adeline Obam and Daniel Lanner, who helped us with the initial prototype for Digipro, and Charles Leflèche, which is extended work in USD and USD schemas at Ubisoft. So thanks everybody for listening, and I think now we're gonna have a Q&A session.
Yeah, if anybody is interested in putting a question in, the chat is open. Christiane's putting the chat in. There's already some questions in there for us to be able to get over to Doug. So if you have questions, they're in the chat.
There we go. All right, sorry about that. I was trying to get myself unmuted. I'm back. So I want to thank you for that. That was near and dear to my heart. Just for background for me, for those that know who I am. So I'm Doug Sherman. I should probably introduce myself earlier on. I'm a vice president of technology over at DreamWorks Animation. Been doing this for 30 years, and I have to say, all the different pipelines I've been involved in, this is all really good stuff. Microservices, URIs, this is all near and dear to my heart. So super happy to see all of this stuff. So let's get to some of the questions. One of the ones, that I can relate to a lot is that the social exercise is sometimes challenging to get sort of hearts and minds on something where your file system's abstract and you're using URIs. I guess, it's one thing to sort of sell this internally, but another to sell it to sort of your third-party development partners. Can you talk a little bit about how the interop is between you guys on the main game and then interoping with collaborators with your USD schemas? How do you distribute those? How do you make sense of that to your partners?
You want to take it, Alex?
Yes. Well, first, this is year 2022 EOC. So we had to make it on pause for the 23 year, for the last year, but we are soon starting rebooting it from starting next April. So what we plan to do is to make the connection between DCCs and game engines, knowing that DCCs support what they support, and Maya, for example, is starting to be better at handling USD scenes. And on the engine side, we have everyone already in-house to work with and start collaborating to use this. But Helix Studio is between those big engines, and we handle data as we want. So we can restrict them so far only on handling. I've seen a question about materials, for example. So far, we don't plan to use materials because it's a really huge topic. We plan to synchronize, as in the last demo, the tools between the animation tools between DCCs and engines, so we don't need anything that is out of the USD scope as of today. We plan to work on the next iteration, like what is Autodesk proposing for the animation curve, for the animation curves and so on. So we will rely on this. Inside Ubisoft, there are many other departments that work a lot on USD, on Material X, on animations, on Maya, on Max, and so on. So there is about 20 people working on engines, and I guess we might find I'm comfortable to think that we might find the good ones to extend USD for our own purpose.
Mm,
One extension, so we are not really tied to external vendors, but maybe sometimes we could talk about open sourcing our own solutions for extending DCCs on features that we created and so on. But vendors are either internally, so we can work with them, and externally we try to stick with what they propose. So
gotcha.
it's not so that much an issue.
Okay. So definitely rewarded by following the standards and not so much invented.
As much as possible, yes.
Yeah, no, makes sense.
But 5 years ago, in 2016, it was much harder to do it for the pipeline for the Railing Rabbit.
Yeah.
We had to torn apart some part of the USD to make a full pipeline handling an in-house tool and Maya by the time, and so we had to make some dirty things into USD. But
Mm.
now, since a few years, we try to stick to the vanilla version, and we might make from time to time at Helix stage, at Helix level, some own schemas to support our own data, but it will be mainly for asset management, like connecting to a shop grid, tracking those kind of data, and really personal to our own needs.
Okay. That makes sense. Just as a sort of aside, well, so USD, like you said, it's sort of over these, especially these last few years, it feels like it's gained a lot of momentum in the community area. So much so there's all this added effort now of companies coming together to help set those standards. Are you are you and your company participating in that? That the sort of are all sort of coming together?
We tried to with the LOD proposal, but we didn't have the right momentum at the right time. So unfortunately, we had to stop just once we released it. But it was the first try to propose something and work with it to share the way we plan to use USD for LODs in the engines, in the game engines, knowing that there are a lot of different LODs in the engines, and that it's the main difference between VFX and games is that for the VFX you are allowed to lock many things for
Mm.
one shot, for the duration of one shot, whereas in games you need to update constantly the LODs, and it could be for geometry, materials, skeletons, skinnings, and so on. So the issue is really harder to tackle, and we didn't have the right time slot to address it correctly, so we had to stall it for the year.
Okay.
But yeah, we this was a miss, but we plan to make other tries.
No, let me let me get into a little more. There's some good questions coming in about specifics around USD in key areas. One of them is this is around importing and exporting particle VFX animation sims between software solutions. So as an example they gave is Blender to Unity. If you have some way you want to pull some amount of artist decision out of one tool and into the next, can USD be used for that for particle VFX animation sims?
As far as I know, yes, but it's not one of our use cases because we will try to be more and more working with in-game cinematics. So particles like shading are really specific to games, to engines.
Okay.
So when you define such topics, you will define it for one engine and some of the time for one game. It's really specific. And besides USD, this is not something that you can expect to exchange between DCCs.
Right.
So as of today, I don't think we will tackle this before a long time.
Yeah, no, we in a sort of similar way, we've had similar struggles in certain areas for asset interchange, like around rigging is a good example too. Like, wouldn't it be
Yes.
great if you could take a rig out of one software solution and sort of respect the rig decisions in another. Like that's I can definitely see the challenge, but it seems like thematically you'll stick to standards. In that vein, and I know you talked about this a little bit, but someone asked it to sort of expand on it if you can, around materials in USD. That seems like sort of a very popular topic with Material X. Um, do you know the specific question is, do you know what's missing in Material X for full adoption?
There is a department actively working on it, and I'm not sure I can say much more about it, but I know that one game that has been shipped was relying on some USD Materialix development made in-house. I cannot tell more on this,
Okay.
but we work on it, and we are all waiting to standardize it. But talking back to rigging, for example, at Ubisoft, we've got rigging systems that are working in every of our engines and DCCs. So for our own purpose, we can try to tackle the rigging, some part of the rigging, with USD because we know we will rely on them for many predictions.
Okay.
Well, if I
So
can just
this
add on that, it's more when you talk about like either materials or some like um, particles or even rigging solution. The key difference is that first of all, your different engines or clients or DCCs, whether or not are they actually all computing the same thing? Like
Right.
is your seed the same? You know, is the output of your and simulation, is it deterministic or not? Because if you have your engine producing particles and this is not the same as Blender, well, it's really, really hard to be able to produce and send stuff around. So you're only limited to be able to either directly stream the data, the outcome or the output of the simulation, or stream the states of your systems. Like when you talk about constraints or rigging, I mean, we have in-house constraint systems, and either being an engine or the plugins in our DCCs, they all compute the same output of that constraint the same way. So if you can guarantee that, or like if you look in Maya or Mobu, if the result of your human IK is the same on both sides, then you can use USD as a serialization method for that.
Yeah, I think that's fair. I mean, I think you guys kind of nailed it earlier on when you guys were early adopters. I can tell you we were early adopters as well. Some of the value of that is you get all the benefit of USD early. Some of the problems it sounds like you might have as well is your tooling is tuned then to something that you had to invent at the in between the spaces where things didn't exist. And so as tools come about to adopt USD, um, and they'll ingest artist decision via those things. So how much of those things are aware of those specific things that you had to sort of invent in the in-betweens? I can definitely sympathize for, I feel like some DCCs are also still on their journey of fully using it as an authoring language as opposed to something that they'll lift the values out of, put in their own proprietary decision engine, and then, that back and forth. And yeah, so again, I'm really impressed with how far along you guys have gotten, given its state where it was when you started and where you are now. So I'm gonna go in. There's a few questions around sort of your process too. One of the earlier questions I got was around your URIs. You kind of flashed it up, and it looked like it was sort of a compound of different things. And the question specifically was, um, in your URIs, is it just a static kind of GUID, even though it's very readable, where your database just takes it as one big chunk, or are you actually parsing the URI and pulling meaningful values out of it to query about what it is you're looking for?
Well, when you look at the URI is meant to be shown to humans, right? So, I mean, it's not just bytes and codes that you just sort of have. So it had to be simple enough for devs and artists and supervisor and CG supervisor to understand and also be able to communicate on the same level. So everybody also have the same understanding of the assets. So some part of it was fixed because we needed to know, okay, what asset is it? It's produced by which team? What is the mandate? What's the project? What's the studio? So that is fixed because and then you version that, right? But the other part of it, the other portion of it, that was depending on like where that asset was developed. So depending on the static part that would tell you, okay, this is produced in the modeling department or the texturing department or the rigging department, then those fragments and queries would change. And then you would have a different set of arguments for that. So maybe some would not make sense. And like in your rigging, maybe you wouldn't have LODs, but then in your geometry department, you would have LODs. So that then is something that it could be defined. But the most important thing of them all is that the definition of that needs to be done with the artist and the supervisors and the developers together. So yeah, that's how we sort of did it. And to resolve it, then well, we had systems that actually will read that URI, decompose it, and then depending on where it's produced and and basically the context that that asset is produced, then they would point directly to where and where to fetch it.
Pretty
And
neat.
to go, sorry.
Oh, go for it. Yeah, I just commented that it's very, yeah, go, sorry. Yeah.
Thank you. Just to go a little bit further, this is not static as it's just one string. It is split into, and it is there are patterns into it. So, for
Gotcha.
example, you will have the authority and the path that will identify an asset, but you don't load an asset into a DCC because you load a resource. For example, when you load a character, you load the animation version of the character. So you identify the asset. Beyond the path, you've got queries that further uniquely identifies the resource. So that's why you start to have format, you start to have the LOD values, you have the status like WIP or published, and then beyond that, you start to have fragments that within a resource, you can start to identify parts of the resource. Meaning that, for example, if you have an asset, let's identify it like this. An asset is a city. With the resource, with the fragment, you can choose which version of the city you want. And with the queries, no, sorry, with the queries, you can do this. And with the fragment, you can isolate one building of the city within a resource. So if, for example, you can hide it, change its version, or do some manipulation for the pipeline on this spot.
Okay,
So
it is dynamic. You can kind of sub out parts. Is it generative at all? Is it always going to reference to pre-existing resources, or if you swap a value in there, can it generate something that's relative to the?
not generate, but identify a new one. The use of URI is to abstract the way you store your assets.
Right.
This way, you can start to think of your asset for the long term, meaning that you are oftenly bound to a file hierarchy, directory hierarchy, meaning that department, project, state, and so on to identify a resource. But once you move a couple of mandates or production later, this hierarchy might have changed, and you start to struggle to find the resource or link it. And it becomes worse once you start to reference in one asset multiple assets. With URIs, you don't rely on the file hierarchy, you just identify resources, and somewhere you have a resolver that says, okay, these tokens in the URI means that I should be looking there. And you have this only part to change when you progress in time, and you still can be able to identify them. And it's even better with cloud storage because it's only one ID at the end.
Right.
So you resolve all those tokens in one ID, and whenever you change production and so on, the references within one of your assets still is available at any point. The next point about URI that is quite useful is that we have one mandatory token, which is the version, and this way you can identify any resource uniquely, meaning that no matter the version of your asset, you can identify one particular texture because this is the one you want. But if you remove this version part, you can say, okay, always take the last on the top of your texture pile, and you're always up to date to the last version. So there are different parts of the URI that are really powerful and that are both for the pipeline, for the architecture, and so on. That brings a lot of solutions.
So I have actually have my own question for this for URIs. I can tell you we have a history of using them. One challenge that we've had is that abstraction. Sometimes the artists get a little grumpy with it because it's not a familiar, NFS or WinFS path that you can just go into a DCC and say file open and it recognizes it natively on the file system. We're still, as much as USD is being adopted natively, URIs short of maybe the attempt to do the open sort of asset IO stuff, largely has been something that hasn't been sort of adopted out there community wise though. How socially, how hard was it to sell the concept of URIs? Because I definitely see the value and the strength in them. I love them, but sometimes selling them to your artist community is harder because of their abstraction. How did that go for you guys?
Artists want their files. Yes.
Yeah.
One thing that will help us to do this, because it's a real question, is that we will introduce the USD server between the artist and the scene, meaning that you will ask the server to load some file. So the artist will not be meant anymore to be relying on some file, on some path, on NAS or locally. They will be relying on some. So this is kind of a cloud approach to the solution where you don't know where it is, you just have it. But it's a big mind shift, of course. One of our struggle to using USD is having DCCs that support them. So there are tricks to make it happen in Maya, but I'm not sure that every DCC can handle that.
Gotcha. Now that makes sense. So this has been so good. I'm realizing it's already 9 o'clock. And there's so many more good questions. Just testament to why we should do more of these and why we want to thank you guys so much for volunteering
Thank
your
you.
time. It's a great community reach out that I think myself and everyone on here appreciates. Since it's 9 o'clock, we're gonna have to wrap this. I know there's another one on Thursday. So please sign up. This one, I believe, sold out and they had expanded to a greater amount of people. So get in if you haven't got in yet for that upcoming Thursday one. And again, I want to thank both of you guys for your time and your effort.
Thank you.
Great slides, great presentation. Thank you. And thanks to everyone that showed up today and looking forward to the next one. And this is recorded. So please share around and looking forward to the next one.
And thanks for the invite and the organization.
Thank you, Doug, and thanks everybody for listening and the great work by the TPC team. Thank you.